Now we are coming to factorization number 3. We have done two of them yesterday, factorization 1 and 2. So I will be doing about 6 or 7 of them. All of them are on your textbook. You can look it up. But what is difficult is you might not be able to understand the steps. That's why I'm teaching it one more time here. No need to focus on the exercise much because the factorization exercise, the factorization chapter, most of the question it is going to come from the factorization 1, 2, 3 that I have been giving from yesterday. Okay. Okay, as a quick reminder to those who joined today, the factorization, we have to follow 3 steps. 1, 2, 3. We have to follow 3 steps. First of all, I have to multiply all the terms, and then we have to arrange them in descending order of a particular letter. Let's say you take A, you have to arrange them in descending order of the power of A. Okay, I have demonstrated it yesterday, right? And then in the third step, you have to take common factor and then you have to repeat. You have to move on to the next letter. We are not going to follow those 1, 2, 3 steps in today's factorization number 3. This is completely different from the rest of them. This is also a very frequented question, okay, for 2 marks. This is not a 3-mark question. This is a question that can be given 2 marks. So let's see. First of all, in order to factorize this, you have to multiply the terms first, open up the brackets. So what we are going to get is, let's start the solution. Start multiplying a square and b, a square and c, b square and c, b square and a, c square and a, and c square and b. So what we are able to obtain, a square b plus a square c, b square c plus. Okay, as I have told you yesterday, again remember, I can write b square a, but I can also write ab square. B square a is the same as ab square. So in order not to confuse ourselves, I want to write the letter a first, b later. That's why I'm not using this way. I will be writing in terms of ab square. So b square and a, we will obtain a b square. Multiply these two also. So c square a plus bc square plus 3abc. This is just multiplication, right? Not a difficult step. The next step is usually we have to arrange the terms in descending order of any of the letter. We are not going to do that in this one. What we are going to do is we are going to break this down. This 3abc. We are going to break it down into 3 parts. ABC, ABC, ABC. We are going to break it 3abc into ABC, ABC, ABC. Right. Okay, let's break it down. We will not change the other terms. You can start copying when I'm writing, but when I'm giving lecture, when I'm speaking, you better stop it and focus on what I'm writing, okay? The knowledge, you have to earn it from the lecture itself, not from the copying. So what we are doing here, 3ABC is broken down, okay? Here. Now, what we are going to do is one ABC will be put in between here. One of the ABC will be put in between here. One of the ABC we will put here. Okay, fix ABC here, this ABC here, and this ABC in here. So let's rewrite them. A square B plus A square C. I'm going to put an ABC in between. So this part is here along with one ABC. And then look, b square c, ab square, 1 abc, we will take it from here. And you always have to remember what terms that we have utilized. You have to take them, this, this, this. You have to put the two of them and one of the abc. So we will write, sorry, b square c plus ab square plus abc plus c square a plus bc square plus abc. It's very simple, right? We are not changing this. This part is here, this part is here, and this part is here. The only changes are the ABC, ABC, ABC. We have kept one here, one here, one. Now there are 9 terms, right? 1, 2, 3, 1, 2, 3, 1, 2, 3. There are 9 of them. We will take common factor of each of them. Okay. If we take common factor of each of them, then we are not going to get any here. It's difficult to take the common factor from these three, these three, these three. So we are going to change some of the terms also. How are we going to change this? There is an AB square, and in the reverse, we will have an A square B. Look, there is an A square B, there is an AB square. Similarly, we have a b square c here, then we have a bc square here. If there is ab, you have to look for the terms which has only ab in them. The powers is fine. Let there be square in a, let there be square in b. No issue. But the terms containing ab, one here, you put them together along with an abc. A square c and c square a. They are the same, right? Not same. The square is on a, the square is on c in this case. So a square b and ab square and then abc, we will put them together. A square b plus ab square plus abc. We're just putting together the terms which has ab in them. Okay. So what are the terms we have used? We have used this term, and this term. Okay, let's tick them off. And then come to a square c. For a square c, it has a and c in it. Which terms has a and c in it? This term right here. So you put them together, this term and this term together along with an ABC. So we will put a square c plus ac square plus abc. What terms have we used? You have to always tick them so that you don't get confused about what are the terms that we have used so far. Okay, we have used all six of them. The remaining six, this b square c, bc square, that has bc on both of them, along with an abc, put them together. All right. So this and this, they have also been utilized. That means we have utilized all the nine terms. We have written all the nine terms from here to here. Okay, now these three, and these three, you take common factor. Okay, take common factor. What is the common factor that can be taken from the first three? There is a on all of them. There is b on all of them. So ab we are taking out as common factor. I'm talking about the first three only. Okay. From here, look, a square b means there is 2a and there is 1b. If we are taking out the ab, what is remaining then? This a is remaining, right? So we will keep it here, the remaining portion. Plus, what about in ab square? Ab square is a into b. There are two of them, the b's. Take out the a and b, there is one of the b's remaining. So from here, we will have a b remaining. From here, if I take out a and b, c will be remaining, right? It's simple. Plus, okay, the first three is done. Remaining 1, 2, 3. What can be taken out as common factor? You look very closely. All the terms have a in them. All the terms have c in them also. What can be taken out as common factor? The smallest power of a and the smallest power of c. You have to remember that. Look, there is a square here. There is a here. There is a here. Which one can be taken out as common factor? Not a square. Okay. But a and a, they are the smaller powers. So you have to take the a as common factor. So what can be taken as common factor from these three is we can take out a as common factor and c as common factor. Write it down. What is remaining from here? There were two a's, one c. One c is taken away already. From the two a's, one of the a's is taken out. That means out of the two a, if one is taken out, one a must be remaining, isn't it? Plus, what about ac square? One a and one c is taken out, so there must be a c remaining. From abc, a and c are taken out. That means b will be remaining. Plus, look at these three. There is b on all of them and c on all of them. We will take it out as common factor, bc. So b and c are taken out as common factor. Out of the two b's available here, one of the b will be remaining. And out of the two c's available in this c square, one c will be remaining. And if I take out b and c, then a will be remaining. Okay, if you look very closely, the bracketed portions here, this, and this, they are all a plus b plus c, right? I can rearrange this as a plus b plus c. I can rearrange this as a plus b plus c again. So a plus b plus c, a plus b plus c, a plus b plus c. Since we have a plus b plus c in all the three terms, I have to take them out as common factor. Okay. Turn off the microphone. Who is turning on the microphone? If you have any question at the end of each factorization, you can ask me. Okay. If you don't know one step, then I can look it up also. I can explain it to you once more. But better don't interrupt the flow during teaching. Okay. So since this is not live, since this is not actual physical class, it's a little bit distracting when you turn on the microphones. So when you have a question, then you can just ask me after this factorization ends. So yeah, we have a plus b plus c, a plus b plus c, a plus b plus c. Take it out, common factor. What is remaining here? ab is remaining. From here, ac is remaining. From here, bc is remaining. So you have to keep them all inside like this. And as I've told you all yesterday, the thing is, in factorization, we want the expression in a cyclic form. That means A, B, C. A will be followed by B, B will be followed by C, C will be followed by A. So A, B, C, this is okay. But the remaining portion right here, this remaining portion right here, it doesn't properly follow this procedure, this cyclical form. A, B, A is followed by B. Okay, it is there. But next comes AC. We don't want that. After AB, we want B and C together. That means after this, we want BC to be put first. And after BC comes, next will be CA. Where do we have the CA? We don't have CA, but we have AC, which is exactly the same. But you have to change it into CA. Get it? So we have to make a little change here. AB plus BC plus C. I brought this here. This AC has been changed into CA. That's it. Very simple. So I want you all to copy this. This is a 2 mark question, probable one, very important one also. So did anyone copy in between? Is anyone finished? If not, you can copy it. I will give you 2 minutes time. Don't take very long. You can also copy in between when I'm not talking also, as I've said. So I'll give you 2 minutes. Copy this. Any question? Any doubts? You can ask now before we move on to the next question.
Sir, the fourth step.
Fourth, one, two, three. This one. You mean this one?
Yes, sir.
Okay, what we are doing here is we are putting together a square b and ab square. If we have b square c, we are putting together with bc square. If there is ca square, then we are putting together with c square a. Very simple here, look. The a square b is here. The ab square, where is it? Here it is. A square b is here. Ab square, I'm bringing it here together. Why? Because we want to obtain a plus b plus c after taking out the common factor, right? So let me underline this portion right here. The underlined portion, they all have some similarities. What's the similarity here? All of them has AB in them. In this case, 1, 2, 3, they all have AC in them. Similarly here, they all have BC in them. That's why I'm putting together B square C and BC square. Just rearranging them, okay? B square C is here, BC square is here. A square B is here, AB square is here. So A square C is here, and then C square A or AC square is here. Same thing, A square C and CA square, they are the same thing. But in between, we put the ABC, ABC, ABC. That's it. Are you able to understand?
Yes, sir.
Okay. Finished? Did everyone finish copying?
Yes, sir.
Who else hasn't finished? Just say once. If you haven't finished, then I have to wait for about 30 seconds. Else, we will move on to the next question. Everyone done? Okay, I'm moving on. Okay, to the next question. Here, look. Number 4, a cube whole bracket b square minus c square, b cube whole bracket c square minus a square, c cube whole bracket a square minus b square. Okay, you might think that you want to do b plus c whole bracket b minus c. You want to break it down like this. No, that's not it. We don't want to work like that. What we want to work is we want to factorize it. One moment, please. So let's see what we are going to do here. We are going to follow the 3-step procedure. 1, 2, 3. Those 3 steps, we are going to follow them one by one. Okay, and let's see what we are able to obtain at the last. So first step, what was the first step? You have to multiply its term, right? Multiply its term. Let's see what we get. A cube b square, a cube c square, b cube c square minus b cube a square. You can start copying. Okay, look. What's the next step? The next step is we have to arrange A, B, or C in their descending order of powers. Look, we have A cube here. Then there must be A square somewhere. There is A square here. There is one A square here also. So we will write the A cubes first, the term containing A cube first, then the term containing A square next, then the term which contains A, if that is available, and then at last the term that doesn't have A in them. All right. So these 2 terms, they have a cube. So we will write them first. We are writing the terms in descending powers of a. So we are going to write a cube b square minus a cube c square. Okay, these 2 terms has been used. I'm ticking them. Anywhere that you are able to see a cube? No, none of them has a cube in there. So what we are going to do is we are going to write the terms which has a square in them. After a cube comes a square, right? Which terms has a square? This term right here and this term right here. They have a square in them. So we will write them in the next step. Minus b cube a square plus c cube a square. So these two terms are also gone. These two terms, I'm writing them here, right? So what is remaining? These two terms are remaining. They don't have any a in them, right? So we will put them at last. All right. So we will write plus b cube c square minus c cube b square. Okay, these two have a cube in them. These two have a square in them. These two doesn't have any a in them. We will take common factor of the first two, next two, and then the last two. Let's see what we will be able to obtain. A cube and a cube, we can take it common factor. So what is remaining is b square and c square is remaining. Look, a cube is outside, b square remaining here, c square remaining here. What about these two? What can be taken out as common factor? A square and a square. I can take them out as common factor. So the minus sign in the front, we are taking out a square common factor. If I take out a square common factor, look what are the parts that are remaining. B cube, C cube. So put the bracket B cube and C cube. Remember this plus sign will be changed into what now? Minus sign, because there is a minus sign in the front of the bracket. So put minus sign here. What about this one, two? What can be taken out as common factor? Both of them has B, C in them. What can be taken out as common factor is the smaller power. Like there is B cube here, there is B square here. But what can be taken out as common factor is B square, not the B cube. You cannot take out the B cube as common factor, okay? And out of C square and C cube, we can take out the C square as common factor. So B square and C square, we will take it out as common factor. What is remaining from here? So B cube, out of the B cube is B square into B. B square is taken now. So there is B only left. We will put the B here minus C cube B square. B square is already taken out. That means C cube is remaining. Out of the C cube is also C square into C. C square is also taken out as common factor. That means only C is remaining, right? Okay. If you get confused here, you better look at what you have learned in class 8. This is just factorization of the algebraic terms. Very simple there. Now, out of the three terms here, do you see any common factor? There is b minus c here. There is no b minus c here, but we can obtain b minus c. No b minus c here, but we can obtain b minus c. In this one, I'm going to break it down using the formula of a square minus b square is equal to a plus b whole bracket, a minus b whole bracket. In case of b square minus c square, the formula will look like this, right? B plus c whole bracket, b minus c whole bracket. Similar thing here, for this one, we are going to use the formula of a cube minus b cube. I have given the formula yesterday. If you forgot, you can look it up in WhatsApp group. I think Sar has posted it there. This will be a minus b whole bracket, a square plus ab plus b square. So in order not to write down the formula again and again, that's why I told you all yesterday to write it down on a piece of paper and post it in front of your study table. Okay, so let me break this down. Let me break this down. This part, we will keep it the same. So a cube b square minus c square is broken down as b plus c, b minus c. Minus a square, look, this part is here. This part is broken down into these two. A square is here, b cube minus c cube, we will break it down like this, b minus c. Okay, you have to understand how I am breaking this down. That's from the yesterday's formula number 4 that I have given. The last part, I will just keep it as it is. Okay, now one, two, three terms. What do you see as the common factor? The common factor is b minus c, b minus c, b minus c. So we will take it out as common factor. The common factor is b minus c whole bracket. You have to put the remaining parts. B minus c is taken away. That means this whole part right here will be remaining. You have to put it here. From this whole term, b minus c is taken away. That means this part and this part are remaining. You have to put it here. From here, b minus c is taken away. That means this portion is remaining. You have to put it here. So what's the remaining from the first term? B minus C is taken away. That means this part is remaining. Keep it here. Minus. This part is taken away. That means this part and this part right here, they will stay. What about here? B minus C is taken away already. B square C square will be remaining plus B square C square. Okay. Since we have already taken out a common factor by arranging the powers of A in descending order, like in this case, we have written a cube first, a square next, and the terms without a later on, right? That's for the letter A. Yeah, we will repeat the three steps again. You'll have to break it down. This no need for breaking. You have to break this down, and then you have to arrange them in descending powers of after A comes B, right? So you have to break it down first, and then you have to arrange them in descending order of powers of B. Okay, let's break it down first. I'm writing a little bit quicker, okay? So a cube B here, a, the screen is wet because of my sweat. So a cube B here, a cube C here, minus a square B square minus a square BC minus AC square plus B square C square. Look, very simple. You multiply these two, we have obtained this. You multiply this, we have obtained 1, 2, 3 here. This is no chance. Now, what we are going to do here is we have to write in descending orders of powers of B. Which term says highest powers of B? Look, we have got a B square here. There is a B square here. We will write them together first. Which terms has B power 1? B power 1 is here. B power 1 is here. Then which term doesn't have B as a variable? This term and this term doesn't have any B in them. We will write them last. So the terms with the highest power of B, this term and this term, we will write them first. Look, no change. I'm writing b square c square first minus a square b square. I'm bringing this over here. This part I'm writing it here. Okay. Now come to the next term. Next term we will have to put the terms which has only b in them, not b square. Okay. The term with the b square are written already. Terms with b only is this one and this one. So let's write them. A cube b first, a square bc next. So better if we write this one first. Minus a square. Okay, sorry, I have to change the color. A square bc plus a cube b. Simple, right? This part is here. This term is here. Follow the steps very closely, okay? Otherwise, you'll get very confused. Take out the terms that we have already written. This is done. This is done. These two terms are remaining, right? A cube c and minus ac square. I'm writing this first, and then I'm writing this later on. Okay, so this part is here and this part is right here. Okay, now these three terms, they have a common similarity in them. Like in the case of these two, the b square is common. In the case of these two, there is only b and b in them. In the case of these two, there is no b in there. So we will take common factor in these two, and these two. What can be taken out as common factor, whatever value it is, you take it outside. All right. So this is a little bit long. This is a question that can be given 4 marks or 3 marks. So take common factor from the first two. We will have b minus c. B square is taken out as common factor. C square minus a square is remaining. Right. From these two, if I take out b square, c square is remaining. B square is out. A square is remaining. What about these two? What can be taken as common factor? B and B I can take out as common factor, right? And look at a and a cube. There is an a square here and there is an a cube here. If there is a square and a cube, what can be taken out as common factor is I can take out the term with the smaller power. I can take out a square as common factor. So a square can be taken out as common factor. B can be taken out as common factor. So we are going to have a square b. What is remaining? Look, b is taken out, a square is taken out. That means only c must be remaining here. What about in this case? B is already taken out, but out of the a cube is, I can write it as a square into a. A square is already taken out, that means one of the a is remaining, right? So you have to keep a here with a minus sign. Why? Because there is plus sign, but it is not plus sign here. Why? Because there is a minus sign in front of the bracket. That's why we have changed the sign plus into minus. Keep the remaining. Between the remaining, from the remaining, what can be taken out is common factor. AC square, A cube, C. Both of them has C in them. From A and A cube, what can be taken out as common factor? I think there is a mistake here. Okay, you copy up to here first. Yes, here look. I have a square missing here. A square and b square, a square and b square, a square and bc, a square and bc, a cube and a square. What can be taken out as common factor is the smaller one. I've shown you, right? I don't know whether by network issue you have missed it out or not. I'm repeating it. A square is broken down into a into a. A cube is a into a into a. So take common factor, this part and this part right here. They are the common. So a into a, we will have a square, which is the common factor. A square is the smaller one, right? If you have a power 5 and a cube can be taken out as common factor, not a power 5. So yeah, a square and a cube, out of them, what can be taken out as common factor is a square can be taken as common factor. And c square and c can be taken out as common factor because c is the smaller term. So I'm taking out a square and c as the common factor. Look what are the term that has remaining. A square c square looks like this. A square into c. We have taken out a square and c. That means c must be remaining. So I can put c here. Since there is a minus sign in front of the bracket, whatever sign inside the bracket will be changed. The plus sign, it will be changed into minus. And look what is remaining from the a cube c. A cube c will be a square into a into c. A square and c are taken out. That means a is remaining. Okay. Look, all the terms has c minus a, c minus a. This has also a c minus a, but it's in the form of c square minus a square. I have to break this down. How? I have to break this down as c plus a whole bracket, c minus a whole bracket. That way, we will have c minus a here, c minus a here, c minus a here, which can be taken out as common factor again, right? Okay, what I want you all to do is you copy up to here. This part I'll give you 1-2 minutes. Let me give you 2 minutes. I think we have already copied somewhere here in the middle already. If not, you start copying very quickly. If anyone hasn't finished, the important thing is you have to have this in your notebook. Okay, the steps one by one, you have to have it in your notebook. So I will wait. If anyone hasn't finished, just say it. Okay, you haven't finished, you have to say it. Otherwise, I'll have to move on to the next step. There is 3 or 5 more steps remaining. Okay, meanwhile, I'm rubbing this part off. Okay, this part of, I'm rubbing off the 1, 2, 3, 4 steps. Anyone who doesn't understand any of the steps, any doubts, you can ask now before I erase off the first 4 steps. Anyone who is not able to understand this 1, 2, 3, 4. Anyone? Speak up now before I erase them. Everyone's good.
Yes, sir. Finish.
Okay. Okay, I'm keeping the last 1, 2, 3, 4 steps. Okay, I'm continuing it here. So let me continue with the green color. Look. From here, what I have to do is I have to break this down. I have to break c square minus a square as c plus a whole bracket c minus a. All the other terms, they will remain unchanged. So it will look like this: b square c plus a whole bracket c minus a whole bracket a square b c minus a square c minus a. Now c minus a is in all of them. So take out common factor outside the bracket and you have to keep the remaining part obviously. So b minus c minus a comes outside. B square whole bracket c plus a is remaining. A square b is remaining. A square c is remaining. From this term, if c minus a is taken out, this part is remaining, right? This is taken out, a square b is remaining. This is taken out, a square c is remaining. So nothing difficult in there. And remember what we have done so far now. We have, first of all, we break down the original expression and then we arrange it in descending powers of A, right? We have done descending powers of B. Now we have to move on to descending powers of C. We have to first break it down. These two, they will remain the same. And then we will start arranging, starting with the terms which has C in them. Get it? So we will have B minus C, C minus A. Whatever stuff inside the bracket, you have to break it down. We have B square C plus AB square. This is A and B square. B square A, I'm writing it as AB square. So no need to confuse here. Minus A square B minus A square C. You keep it as the next step. Now what we have to do is we have to write the terms that has C in them. Which terms has C in them? This term has c in them. This term has c in them. There is no square or cube. That's why we are just putting the terms with c first. Terms without c, we will put them later. Okay, I'm rubbing off one more step. So, little bit of a rearrangement. We're putting b square c first, a square c next, ab square next, and a square b. This is here, this is here, this is here, this is here. We are just putting a term that has c first. Now, time to take common factor. What is the common factor between these two? Obviously c, right? C is the common. What about between these two? It has a and a square. What can be taken out as common factor from a and a square? The smaller one. So from these two, I have to take out a common factor. From b square and b, I have to take b as common factor. So I'm putting c first, b square minus a square next, plus ab first, b minus a next. In case you get confused, I'm explaining it again. From these two, c is outside. So b square is here, a square is here, simple. A square, b, a and a square, the common is a. B square and b, the common is b. So ab square, if you break it down, this will be ab into b. If I'm taking out ab, then b is remaining. That's what I'm putting inside the bracket. A square b, this is a into ab. I'm taking out ab outside. That's why there is a only. So I'm rubbing off all the steps. B minus C minus A. What to do next? We want to take out a common factor again here. You seem to see B minus A here, B minus A here. We will obviously have B minus A from here. How? By breaking down it as B plus A and B minus A. Okay, let's break it down. C B plus A, B minus A plus AB, B minus A. Right. This is broken down into these two parts right here. So common factor now, b minus a is common factor. You take it outside. And what are the terms remaining? We have got this part remaining and this part remaining. This part, keep it c b plus a plus ab. So nothing to do here anymore. We have arranged descending power of a, descending power of b, descending power of c. So you just open the bracket, just do the multiplication, and b minus c whole bracket, c minus a, b minus a. Then inside I'm putting it as bc plus ac. Sorry. Look, c and b, bc, c and a, ca, and ab is ab. No change here, okay, just multiplication of this part. Okay, remember we want to write the expression always as cycle form. A, B, and C in cyclical form. Let's see we have the cyclical form or not. A to B. Do we have A to B here? No, we don't. This is B minus A. What we want is we want A minus B. As I've told you all yesterday, B minus A, how to break it down, how to change it into A minus B? Just put A minus B. If you have x minus y, no. If you have 1 y minus x, if I want to change it into x minus y, I will have a minus sign in the front. So this b minus a, if I want to change it into a minus b, we will have a minus sign in the front. So if you bring it up in the front, we will have a minus b, but with a minus sign. After a and b is done, next will be b to c. Here it is. So no need to change this. This is perfectly in the shape that we want. So just keep b minus c here. Next is c to a. Do we have c to a? Yes, c minus a. And here also in these three terms, 1, 2, 3, you have to write in this order. AB first, BC next, CA later on. Okay, so I'm writing this AB first. Next will be this BC, and at last the C. Okay, so rearrangement. That's it. So this is your final result for the factorization of this part right here. This is very long. I think there might be at least about 10, 12 steps there. So don't try to memorize it, okay? Don't try to memorize it. The only formula you need to understand is a square minus b square. What's the formula of this? And what's the formula of a cube minus b cube? If you understand this, with enough practice, this is a very easy part. We have to wind up today's class. We will take up 2, 3 more factorization tomorrow. And day after tomorrow, I think we can finish the factorization chapter itself.